Today we're installing the first fuel cell micro CHP unit in the UK. It's the first commercially available unit, and it's a joint development between Panasonic and Viessmann. It's also been MCS approved, so we'll benefit from any subsidies that are available.
We think we're an average family. It's two young kids going to school, and obviously a lovely wife, and now a puppy as well. So the house is just a normal house. 100 square meter in floor space area. So I think from the energy consumption point of view and so on, we are average. I like technical challenges, I like technical innovations, and my current system uses a Viessmann boiler with weathercom system, and I'm always keen to go the next step forward, generating my own electricity. And yeah, in one point I'm doing it because I'm fed up with the high electricity bills. I'm paying around about £600 a year on electricity. The costs are going up and up and up. It will not go down.
It takes proven technology of the Panasonic fuel cell in combination with the experience of the heating and controls technology from Viessmann and puts it into one unit. It is relatively simple to install in that the connections that you would expect for a gas boiler are the same for the fuel cell unit. You need a gas supply, you need a power supply, it has hot and cold water feeds, and you need a flue. So the installation takes around 2.5 days. As a fuel cell, it's an electrochemical process, so it doesn't burn fossil fuels. It converts natural gas into hydrogen, and using that process creates both heat and power. That operates for the majority of the day, creating the heat for the home in heating water and domestic hot water, and also the energy that you would use throughout the house. Electrical production from that is around 4,500 kilowatt hours per year, which is typical for a UK home. To get the same equivalent electricity from solar photovoltaics as from the fuel cell, we would need approximately 30 square metres, which is equivalent to the whole roof from a fairly well-sized property. The backup boiler is there because there are around 30 days in the year which are the coldest days of the year, and for those we need peak demand. We need the boiler to produce as much heat as possible. If we are going to reduce our carbon emissions and make ourselves more energy efficient, then we will need to find solutions for gas. This unit will save homeowners around 36% on their energy utility costs, and as well as that, the electricity that you're producing on site is around twice as efficient as relying on a centralised power station.
This system will give me the opportunity to generate as much as electricity a year as I use. The other thing is, obviously, I want to do something for the environment. Of course, some of the electricity will be exported into the grid on times when I don't use the electricity as much, so the fuel cell produces more than I need. Overall, throughout the year, it balances itself out, so it's even. The benefits for me, there are some feed-in tariffs, I can tap into it. So utilities are providing me with a feed-in tariff for every kilowatt hour produced electricity of around about 15 pence per kilowatt hour I get from utilities, which is very, very good. So from that point of view, I'm expecting an annual saving of around £600–700.